Hello everyone, welcome to this video in the decision tree from scratch series. In the previous video, we looked at Gini impurity. We looked at the mathematical definition of the Gini impurity, and then we also looked at the graphical visualization of it. We compared it with another metric which classifies the leaf impurity, and that is called as the entropy. So we ended the last lecture at this point where we calculated the Gini impurity for two questions, loves movies and loves cartoons. And in this lecture, we will calculate Gini impurity for numeric data. If you are tuning into this lecture for the first time, I will give a brief walkthrough through the problem which we are trying to solve. But I will still highly recommend to watch the initial lectures in this decision tree from scratch series. So let's get started with today's lecture, in which our main goal would be to calculate the Gini impurity for numeric data. So let me recap the problem which we are trying to solve. This is the training data which we have. We have interviewed 7 different people and we have collected the responses which they give for 3 questions: loves movies, loves cartoons, and their age. And then we have also collected the responses for whether they love Batman. So in the loves movies, the responses of the people are either yes or no. In the loves cartoons, it's either they love cartoons or they do not love cartoons. And then we have noted down their age. And then we have also asked these people that do you love Batman or not? And then we have noted down whether their answer is no or whether the answer is yes. This is the training data which is available to us. The goal or the problem which we are trying to solve is that based on this training data, we want to use it to predict if an entirely new person loves Batman or not. So, for example, if you meet a new person, let's say based on this training data, and ask them that do you love movies, do you love watching cartoons, and what is your age? Just based on these three pieces of information about the new person, can you predict to the best of your abilities that whether that person is going to love Batman or not? This is the main problem which we are trying to solve. And in the earlier lectures, we have looked at, although this looks like a classification problem, yes or no, logistic regression is not the right approach for it. So we are going to look at a decision tree approach. In fact, we are going to build an entire classification decision tree from scratch. So we know the end goal which we want to reach. The end goal is a classification tree which looks something like this. You can call it the true answer or the true classification tree which we want to construct from scratch. So let's look at this tree. First, you ask whether the person loves cartoons or not. If they say yes, you ask their age. If it's less than 12.5, you can confidently say they do not love Batman. If the age is greater than 12.5, you can confidently say that they do love Batman. On the other hand, if their answer to the first question, whether they love cartoons or not, that itself is no, you can immediately say that that person does not love Batman. You can check these for all the training data which we have. Let's say we look at the first person. Let's say we ask them, does the person love cartoon? Yes. So it goes into this category. Is their age greater than 12.5? Is their age less than 12.5? Yes, indeed. So then it goes into this category. So we will predict they do not love Batman, and indeed we can see that this person does not love Batman. So you can test this classification tree on all these 7 training data which I have, and you will see that it is correct. The goal for us is to build a classification tree like this from scratch. So for example, there are a number of questions, right? The first question is, what should really be in this root node? Why did we choose this question of loves cartoons in the root node? Why not choosing the question of whether they loves movies or what is their age? Those also could be in the root node, right? So in the previous lectures, our main goal is to try to find out what should be at the root node. So the main goal which we have been at in the previous lecture and the lecture before that is how can we decide the root node? And we have made significant progress. In fact, when we concluded last lecture, we have reached this stage where we constructed a decision tree map. So this is what is called as a decision tree map. We constructed this map for two questions: loves movies and loves cartoons. And then based on the decision tree map, we calculated something which is called as Gini impurity for these two questions. So the Gini impurity is defined by a mathematical formula. Gini impurity for a leaf is 1 minus the probability of yes whole square minus the probability of no whole square. So if you do not know what this means, kindly look at the previous lecture in this series. So we computed this Gini impurity for the loves movies question, and it turned out to be 0.405. And we calculated the Gini impurity for the loves cartoons question, and it turns out to be 0.214. So mathematically, the Gini impurity for the loves cartoons question is lesser than the loves movies question. And that's why when we decide the root node, the loves cartoons should definitely be given more priority over the loves movies question. Why? Because if we have more impurity, which means that we are not doing a good job of classifying whether the person loves Batman or no. And in loves movies, the impurity is 0.405, which is almost two times that of the loves cartoons question. So in the last class, we reached the conclusion that great. So we should definitely prioritize loves cartoons as the root node more than the loves movies. But that still does not answer the question, what about age, right? So now you have decided that at the root node, loves cartoons should come over loves movies. But what about if I ask the age of the person first and then I do the branching from that? So why cannot we use age as the root node? And today is all about that. Today we will compute the Gini impurity for age. In fact, if you see, age is a bit different than the other questions, right? Because loves movies and loves cartoons, the answer is either yes or no. But age is a numerical feature. It takes numerical values 7, 12, 18, 35, 38, 50, 83, etc. So the procedure for finding the Gini impurity for numerical features like this is a bit different. So let me walk you through the procedure right now. So let us just focus at the age right now. So if you look at the age column, it's 7, 12, 18, 35, 38, 50, and 83. And we have also documented whether the person loves Batman or no. So it's two no's, three yeses, and two no's. Great. So the first task which you have to do when you are given a numerical features like these is that you have to sort that numerical feature from the lowest to the highest. So let's see if that is done for the age. We have to sort this from the lowest to the highest, and we can see that it's already sorted from low to high. If you are working with a new classification tree and if you have a numerical feature which is not sorted, the first step is to always sort that feature from the lowest value to the highest value. Great. So this step is done right now. Now we move to the next step. The next step is to calculate the average age for adjacent rows, which means that here I have six rows, right? Actually, seven rows 7, 12, 18, 35, 38, 50, and 83. So I will look at adjacent rows. So first I will look at 7 and 12, then I will look at 18 and then I will look at 12 and 18, then I will look at 18 and 35, which are these two. Then I will look at 35 and 38, which are these two. Then 38 and 50, these two. And then 44 and then 50 and 83, which is these two. So I'll find the average of each of these pairs. So first I look at 7 and 12, whose average is 9.5. Then I look at 12 and 18, whose average is 15. Then I look at 18 and 35, whose average is 26.5. Then I look at 35 and 38, whose average is 36.5. Then I look at 38 and 50, whose average is 44. And then I look at 50 and 83, whose average is 66.5. So here I have written the average age for the adjacent rows right here. That's the second step. And so the second step is calculating average age for adjacent rows, and we have completed this step right now. So I've marked it with a tick symbol. The third step is to calculate the Gini impurity for each age. So now if you look at the average ages, there is 1, there is 2, there is 3, there is 4, there is 5, and there is 6. There are 6 different ages which I have, right? So I will find the Gini impurity for every age. So let's see how that is done. First, let's look at 9.5. So I will ask the question, age is less than 9.5, and then I will construct a decision tree map for this. Decision tree map. So if age is less than 9.5, it splits into two categories, yes and no. And I want to compute Gini impurity. So first I will look at the final goal, loves Batman. And then I will look at how many yeses and how many no's are there. So first let me look at the yes category. So if age is less than 9.5, which means it's only 7. So we have one no and 0 yes. So we have one no and 0 yes. Similarly, if I'm in this category, which means age is greater than 9.5, so if age is greater than 9.5, then it's all of these, right? So which means there are three no's, 1, 2, and 3, and there are three yeses. So I'll write here three yeses and three no's. So remember, when we find Gini impurity, it's defined for every leaf. So here the left leaf I'm calling leaf number 1, and the right leaf I'm calling leaf number 2. Both the left and right leaf will have their own Gini impurity, and then I will take a weighted average to find the total Gini impurity. So to find the Gini impurity of the left node, it is 1 minus the probability of yes whole square minus the probability of no whole square. What's the probability of yes? It's 0 divided by 1, which is equal to 0. So I've written 0 square. And what is the probability of no? It's 1 divided by 1. 1 divided by 1. So I've written 1 square here. So the Gini impurity for leaf number 1 here is 1 minus 0 minus 1, which is equal to 0. And this you already should have predicted, because this leaf is pure. There is not a mixture of classes here. There is only the no category here. If you look at the second leaf right now, the probability of yes is 3 divided by 6, which is equal to half. And the probability of no is also 3 divided by 6, which is equal to half. So the Gini impurity of this right node, which is a right leaf, which is leaf number 2, is 1 minus probability of yes whole square, which is 1 minus 1 by 2 whole square, minus probability of no whole square, which is 1 by 2 whole square. So the probability of the right leaf, leaf number 2, is 0.5. The probability of the left leaf, which is leaf number 1, is 0. And now we have to take a weighted sum of these, right? So let's look at the number of people who have answered. In the yes category, there is 0 plus 1, which is one person has answered. In the no category, there is 3 plus 3, which is 6. So totally there are 7 people. So when I take the weighted average, I will multiply the left leaf Gini impurity by 1 by 7, and I will multiply the right leaf Gini impurity by 6 by 7, because the right leaf has 6 people. So the total Gini impurity is 1 by 7 multiplied by 0 plus 6 by 7 multiplied by 0.5, which leads to 0.429. So for age less than 9.5, the Gini impurity is 0.429. Similarly, if you can see, I have made 6 columns here: age less than 9.5, age less than 15, age less than 26.5, age less than 36.5, age less than 44, and age less than 66.5. These are corresponding to the 6 ages which we have: 9.5, 15, 26.5, 36.5, 44, and 66.5. In each of these, I have calculated the Gini impurity. So for age less than 9.5, the Gini impurity, as we calculated, is 0.429. For age less than 15, the Gini impurity comes out to be 0.343. For age less than 26.5, the Gini impurity comes out to be 0.476. For age less than 36.5, the Gini impurity comes out to be 0.476. For age less than 44, Gini impurity is 0.343, and for age less than 66.5, Gini impurity is 0.429. So if you have not done these calculations, I highly encourage you to pause this video and do these calculations for all the different ages. I have already done for age less than 9.5, and here actually I have done the calculation for age less than 15 also. For age less than 15, on the screen I am showing the entire calculation, which gives you the Gini impurity of 0.343. Similarly, you can use this as an exercise to find the Gini impurity for age less than 26.5, age less than 36.5, age less than 44, and age less than 66.5. When you do these computations, you will get these answers, which I already showed you above. For age less than 9.5, the Gini impurity is 0.429. For age less than 15, the Gini impurity is 0.343. For age less than 26.5, it's 0.476. For age less than 36.5, it's 0.476. For age less than 44, it's 0.343. And for age less than 66.5, it's 0.429. Now, if you look at all these Gini impurities, we have to select that particular age which has the lowest Gini impurity. So if you look at this list of Gini impurities, you will see that there are two lowest values of Gini impurity, 0.343, and that is given for age equal to 15 and age equal to 44. I have also written that here the lowest Gini impurity is 0.343, and that comes out to be for age equal to 15 as well as age equal to 44. So the next step is that we have to pick either one for the root node. So I'm just going to pick age equal to 15 for now. So I pick age equal to 15 because among all the different ages, it has the lowest Gini impurity. So here is the decision tree map for age less than 15. So let's see if this makes sense. Age less than 15, if we go into the yes category, let's see. If age less than 15, if we go into yes, which means over here, right? Age less than 15, there are two no's and there are zero yeses. So age less than 15, there are two no's and there are zero yeses. And let's see age greater than 15. So if age is greater than 15, which means we are over here, these ones. So there are three yeses and there are two no's. Let's see if that is correct. So for age is greater than 15, which means we are here. There are three yeses and there are two no's. This is exactly what we have written in this decision tree map. So this is the Gini impurity. So if we choose age as the root node, then then the Gini impurity will be 0.343. Now let us actually choose the root node. Now we are in a situation where we can choose the root node because we have found the Gini impurity for all possible questions. When we started the lecture, I showed you the Gini impurity for loves movies question and for loves cartoons, right? Now we have calculated the Gini impurity for age also, which is 0.343. Now let's see all of them at a glance and see the Gini impurities. If we ask loves movies question at the root node, that is whether the person loves movies or not, then the Gini impurity turns out to be the highest, which is 0.343. If we ask the loves cartoons question, then the Gini impurity turns out to be lowest, which is 0.214. And if we ask the age question at the start, then the Gini impurity turns out to be in the middle, which is 0.343. So if you compare all of these, it still is pretty clear that the question which you should be asking at the root node is whether that person loves cartoons or not. This should really be the question which you should be asking at the root node. And we have proved that right now through a mathematical metric of Gini impurity that you should not ask the loves movies or the age question at the start because they lead to higher impurities than if you ask the love cartoons question at the start. So because Gini impurity of love's cartoon is the lowest, we have selected that as the root node. So with this lecture, we have completed the first very important step of building a classification tree, and that is to find the root node. We found the Gini impurity for the loves movies question, and we found the Gini impurity for the loves cartoons question, and we found it for the age. So we have found it not just for binary data, yes and no, but we have learned today how to find Gini impurity for numerical data as well. Great. Now that we have decided the root node, let's see where we are at what stage in building a classification tree. Our goal is to reach a classification tree like this, which we know leads to the best answer. This is the final answer, which is the true answer. We know we want to reach here. But up till now, we have finalized the root node. Until today's lecture, among the three questions, whether the person loves cartoons, loves movies, and age, we have made the choice that loves cartoons is the best question to ask, and then we have finalized the root node. Great. In the subsequent lectures, we'll be dealing with the next part of the tree, what should come at these intermediate nodes, and then finally the leaf nodes. So we have already started building the tree, and I would say around 33% of the tree is complete. We have selected the root node. In the subsequent lectures, we'll move further down the depth of this tree and see which questions should come next. As always, like in the previous lectures, I'm trying to make these set of videos intuitive plus graphical in nature. Like I say at the end of every lecture, I could have directly shown you the Python code for Gini impurity and for this problem, but then you would not understand the basics of how to calculate Gini impurity. I have seen that the student who understand the basics, they really master decision trees very well. And these set of lectures is an attempt to teach you right from the basics. So in the next lecture, we'll dive a bit deeper and we'll look at further nodes of the tree, and we'll continue constructing the decision tree further. Thank you so much, everyone, and I look forward to seeing you in the next lecture.